So we're now in the root directory. So this does require some GitHub knowledge. I'm not here to teach you about GitHub. I'm here to teach you about data modeling. So what you had to do is you had to clone, or you had to copy and clone the organization, the repo onto your machine. Make sure you have it in somewhere that you know where the GitHub is, that directory is, the root directory. Did anyone do that successfully? Yes. Okay. So we did get people to do git clone, and you were in there. You got it on your machine. Great. I want to make sure that worked. I should test that out beforehand, but I'm glad it worked. I'm glad I got some hands. So we git clone. We bring that down, and then we are left with January 2024. This is not the root directory. The root directory was one level up, which was the whole data engineering quarter, but this is the specific file for January. So if you're able to get this far, fantastic. If not, I'm sorry. This next part is not so hard. So I want to make sure we're able to talk about that. We have master file and working file. We're going to work off the working file, but the master file is for when I'm stupid and I forget something and I have to go back to the master file and figure out what that fill in the blank thing was, because I'm not going to remember everything.
Yeah. Just maybe enlarge stuff.
Oh yeah, it's super small right now. I'm not going to stick to this. These things are not to talk about right now. They're more for you on your own time, just to give some more context. Here, this thing is important for this is the data that we're going to work off today. So you don't have to run this. You can run this if you want. The main thing here is the number of records. It's currently set at 2 million. I have 2 million records in a JSON file that we're going to work with. If you want to run this code, just change it to 1,000. This is going to take you 10 minutes to run that code and to export 2 million records into a JSON. So if you do decide to run it, just change that to 1,000 before you do something with it. And then you'll need Faker. So you'll have to do, this is the requirements file. You have to have the requirements installed in your virtual environment. Before you do that, then you'll run this file. This file should run fine once you've installed all your requirements in your virtual environment. And this is what I meant to say on the the meetup stuff, that there is a prereq here, and the prereq is assuming that you know how to do that. Because I don't want to focus too much on that. I want to move into data modeling stuff. That's what we're talking about. Is anyone working along with me, just so I know to gauge how I'm moving? Working along with me? Anyone's okay? We got some people working along with me. Okay, cool. I'm assuming if you get cloned and hold it down, that you're trying to work along with me. So I want to make sure I move at an appropriate pace. Cool. So, please don't open. Create DuckDB working file. That is not the name of this file, but it is what's going on. So nothing really important happening here in this first cell. This first cell, all we're doing is just setting our path and bringing the data in. I've had a lot of issues doing this at companies and setting the path to make sure it's the right path for everyone. This is how I normally turn to that approach. If this didn't work for you, I'm really sorry. But this is usually my best bet at just using the pathlib. When we're running it as a PI file, we can use this _ file. When we're just running it in Jupyter like we are right now, just using the absolute parent from pathlib. Definitely recommend using pathlib when you're working with paths. Don't just hardcode paths. Use something that allows you to work with a file directory. We called our file transactions multi-threaded. That's how it's called in the first file. Ideally, you've parameterized that somewhere else when you're running this. But then what we get to is the exciting part after this. So we're going to read in using DuckDB SQL. DuckDB SQL, again, you'll notice in here, this is just a SQL command. And all it's doing is selecting star from, you'll notice it's a JSON file. DuckDB is really cool. I can just tell DuckDB to go grab the JSON file and bring it in, and all of a sudden now it's a SQL table. So we love DuckDB. There's one thing that needs to go here in the fill in the blank, and I'm pretty sure it is read JSON auto is the command that goes there. You can get, let me just make sure, read JSON auto, yes it is. You can get fancy with this. You can define the exact schema to expect inside of the JSON. There are ways to define that stuff. Just this one worked out really nicely where I just told it to, you do it. You do the work for me, and we'll see how it goes, and it went really well. So we were able to do that with the JSON data. I am going to execute this code. If you're on the Wi-Fi, it's the AIA guest. I forgot to mention that. There's an AIA guest network. That's the one that I'm on and I'm using for this. So hopefully we're able to do that. I might have just chosen the wrong environment. It is okay. Path environments. I have a lot of environments, as you can see. There it is. That's the one I want. Now we're going to run the code whenever this thing decides to load. All right, but we'll talk about the next things that are coming, because we can do this without it. So the next thing that happens is we just create a connection to our instance. So this right here is why we're using DuckDB. Because had we had to set up a Postgres instance or a MySQL instance, like there would have been a lot more work to get a database like ready on our computer. But because of what DuckDB allows us to do and the functionality it gives us, we're able to run DuckDB Connect. We just give it a name. So you'll see over here duckdb.db in my file structure. That's just because that's what I called it right there. Like you can change this to anything and it'll be called that in your file structure. So now I've got a database that is, you can set it to read only, false or true. So you might have one that is like a read only. You might have like a read write copy of that. And then you might have another one that's a read only copy. So you can make sure you have consistency across, something like that. You can create a pi relation. So what is a pi relation? It essentially, you notice the connection is what we're using from Dataframe JSON data. So we loaded the JSON data into a data frame. You'll see the fetch df here on the end of that duckdb command. We now have this JSON data using duckdb as a pandas data frame in our environment. So we're working with a pandas data frame loaded from a JSON file using duckdb. Really wild stuff going on in the beginning to make these things possible. And then you'll notice the connection that we established pulls that relation. And why are we going to pull that relation? It's because we need to be able to work with it in SQL. Otherwise, we wouldn't be able to work with it using the DuckDB SQL. That's why we have to define the relation, the pi relation there. That's a DuckDB specific thing just to enable this workshop. So here, you'll notice the create schema, if not exist, landing. So we're just creating a schema that we're going to send that data to. And the create table, if not exist, just going to be landing.transactions. You'll remember that image I had where we got the data, we moved it into a landing.transactions. That's what this is. And then you move it into the next part, which is what we're going to do here. You'll display as a pandas data frame, select star from landing transactions. All we want to do here is limit. So this is just going to limit the amount of data we work with. Limits are not great for like pipelines and production, but they're great for developing and kind of working with smaller amounts of data. Has anyone like executed themselves and like is getting these things to work? Or are we having troubles, or are things working all right? Want to gauge that?
I've created the directory of my creating stuff. I'm working on it. This is the first time with Python.
Yeah. Okay. Yeah. So Jupyter is just our way of like executing one by one and like making sure like we can run things kind of in smaller chunks. So I don't like Jupyter, frankly. I hate working in notebooks, but for like the purpose of a lab, like these are really great to kind of like walk through step by step. Anyone running alongside me right now? Executing? Okay. Okay, next step. So now that we have, ideally we'd be able to see this, and I don't know why this thing is taking so long to load. That is my only downside, is this environment does not want to load. We'll have to do Pine shell, and it's going to be full stack. Yeah, so that loaded, no problem. We will restart the kernel. Usually when you turn it off and turn it back on, things work all right. Nope, don't want to connect to code space. Code, open that back up. Going to close out and bring it back so that way I can actually execute code, because that is going to be one important piece of this entire workshop. So that way those who aren't following along are able to see what's going on, because otherwise things are not going to make sense. All right. See if that worked out all right for us. All right, great. It did work because the code at least ran, but it does not like, oh, I forgot to bring the data in. It's because I forgot to run that. Okay, so we're going to go back to the create fake data. We changed it to 10,000, and I will make sure I have my environment working, because that's what's going to be need
analytics to the data side. So I love working in notebooks and having a Python notebook up and being able to write SQL or be able to write stick with pandas Dataframes if I can.
Yeah.
It feels wrong to be able to do that though. It feels like it's convenient for me, but there's some cost somewhere. Like, oh well, there's SQL mixed with pandas, mixed with whatever other tools you can pull in.
I feel like I planted you right now in the audience. I didn't even think to talk about that, but yes, there's definitely like in a production system, you really wouldn't want to do this. Like this is not going to be a best practice to like have a like trying to schedule and run and execute like a notebook that has both Python and SQL like running inside of it. And when you're jumping between like context and dialects, also this like we see this requirements file like. In order for all this code to work, I have to ship all of these requirements to like a production system. Like I have to have like a Docker container that's sitting in EKS on Amazon that has all of these requirements like baked into that Docker container in order to productionalize something like this that has both Python and SQL running inside of it. So I guess the downside of this specific file, right, in a production sense, is like if I have to ship it with all of this, it's going to get really big. And that's going to be really annoying. Also, I can't unit test SQL code. So like, how am I going to unit test this? Like, what am I do with this? Like that's also like, it's a very common thing with like Spark SQL that people kind of harp on Spark SQL. Is like, I can't unit test Spark SQL. Like, how do I ensure like reliability of my pipeline and like, how do I handle like errors in my pipeline or make sure that the code that I even shipped is right in like a CI/CD context when I can't test the code that I'm shipping if it's all baked into like a SQL context inside of a Python file. Like how do I even go about doing that? It's not something that I've investigated too much right now with this specific use case, but there are ways, like this is a really deep, like this conversation could go really deep, but there are ways that unit test these things. It just requires a lot more thought about like OOP and FP and thinking of like functional programming and object-oriented programming. How do I make sure that like you'll notice my SQL code here is 2 common table expressions and a select star with a product extract that we'll get to this fill in the blanks in a second. One thing here is like you want to keep what's happening there really small. You don't want to do a lot of operations at once. You don't want this to be 500 lines of code. You want this to be like it has one purpose. And then if this has one purpose and it's in Python, you really could unit test it at that point because you could like turn this into a function. You could define the like fake input and expected output of that fake input, and you can now unit test SQL code, which turns that downside into now an upside of using SQL in Python. But again, we get back to the shipping like all of these different things to a production system. So we can go really deep into like pros and cons about this. Yeah.
I hate to jump ahead, but first of all, Docker container, isn't that what it's supposed to do? Is allow you to go easily production? And number 2, you can just put that into a Docker container.
Yes. But you would want your Docker container to stay as small as possible, right? Like you want to keep your Docker container small. The only thing right now, like this requirements txt, I wouldn't want to send this to a Docker container right now because of things like Jupyter Client, Jupyter Core. Like I'm not productionalizing Jupyter notebooks. Like I definitely don't want that to ship with my requirements file. Pyro, I have right now, but like I don't really do anything with Pyro in my flow, so like I need to validate that like if I have a library in here that I'm actually doing something with it, and is it really necessary? Could we do this in another way in a production that like keeps it smaller? Could we schedule SQL code? So we have a tool called dbt. dbt is a really great tool in the data engineering space that allows us to do a lot of that stuff just using like raw SQL, so we don't have to kind of have a Python wrapper for SQL. So that's a really great question. I could go on for an hour about this stuff. I'm gonna try not to. So we're getting back to what's happening here with this list struct that's in this column. So again, the list struct in the column, all that's happening here is a row number because I was trying to filter. And the row number is great for filtering. Tab that over. Okay, so now that we've filtered down the data set a little bit to the 20,000 rows, we have a products column is of type list, which we need to extract. In this, it is 1 index. Python is a 0 index language, but this is SQL code, so this is going to be a 1 index. So from here, you notice we're pulling products 1. So we're going into the products column and we're pulling out the first entry. And again, what is the first entry? The first entry in that list is a structure. The structure that is like a JSON. So we're telling it, get rid of the list, like just throw the list away and just give me the JSON that comes inside of that list. So we could have more items in that list in a certain instance, but we really wouldn't want to. We want to make sure that this is just products one. And that's how we created the data. I created the data, so I had to tell it that it's only a list of length one. But I mean, there's instances which sure you could have a list with other things in it. And like I said, I was gonna forget, so here we are. List extract is what's gonna go here. So this is again a DuckDB specific command, but every data lake tool, like S3, GCP, Snowflake, Databricks, every data lake tool is gonna have their own command to extract a list. Right, done. Now we have, maybe I should have shown here what we have after this. Now we just have a JSON format, which is just a dictionary with keys and values. So we can unpack the struct type. You notice products extract is what we call it here. When we name our column products extract, we refer to products extract here. And then guess what? This part is really hard. It unpacks it because the keys are the column names and the values are the values. So now we just have 3 columns, because before a struct actually had 3 entries in it. It had product ID, quantity, and price. And so that was the struct. It had a length of 3 with 3 key value pairs. Those 3 key value pairs got unpacked, and now they're 3 separate columns. So we're going to run that code so you can see. Oh, and also here we're converting it to pandas and doing an iloc so we can look at the end of that data frame. So you see the last 5 columns of the data frame right now. We have the row number on it, which was how we filtered it down earlier. You see that products extract, but then you see how it extracted, right? Product ID, quantity, and price. That's amazing. All I did was put a star and it pulled the whole thing out. That's really cool. So now this is something I can actually begin to work with, right? I couldn't really work with this. This though, when you get to like really large scale data engineering, this is great. Like that you can ship complex types in a cell, because now we're talking about like this, when I built this with the 2 million rows, expanding it out, like blowing it up and unpacking like product details, like all of this stuff, I went from 2 million rows to 7 million rows. So like my data size blew up when I needed to actually like blow this detail out, because there could be multiple products kind of going on here, and each product is getting its own line item. So the fact that you can pack complex types in a column is really, really good. You should definitely do that when you're working with other data engineers, or you're working with like a system that can handle that. When you're working with the business, we need to make sure we're working with like more primitive column types like integers and strings and other things like that. But definitely don't shy away from using complex types, which is why I wanted to include it in here, so you can know that you probably see it at some point and you can actually use it in really, really cool ways for when you're building pipelines. And one thing I wanted to, actually before I move on, anyone have questions about like complex types? Yeah, because this is something that I want to spend a little bit of time on for sure.
So, okay, just a quick thing. The name is list struct, right? The name
Well,
of
so
the complex type is list struct.
you see, you have a struct wrapped in a list. So the list is the outer type and the struct is the inner type.
What is it called? Is it called something in Python?
This is like a common reference, like universal. You could use like list struct. People are gonna get like what you mean. Like you have a structure, that's like a type of thing, and you have a list that wraps that structure. It's just all over, universal. Yeah.
So we have metadata for the JSON file.
What's that?
The metadata.
Yeah, we made the data into the JSON format. Like so the right here, you see the products extract. This is JSON essentially.
So I need metadata in the data description. So do we have the metadata for this JSON?
Oh, do we have the metadata for like what is each piece of the JSON for this specific file? No, we don't have any metadata on it right now. Yeah, you asked your business partner, and your business partner said, I don't know, that's just how we always done it. Where's the metadata? Oh, we don't have metadata. It's a good question, though. Definitely something to be thinking about.
Maybe I missed this. Was the struct, could it be a variable number of products? Or the
Yeah. definitely. It can be anything from one product to 1,000 products. Yeah.
So when you do the unpacking and break it up like this with the structure, it's gonna then put one item per row.
Yeah, it's not immediately obvious that it's doing that, but yes. So it's pulling out. And this struct type is of, if I could pull out the length of this struct, it has like, when these things repeat themselves, like when the product ID is going to repeat itself, it's going to break that out into a new row. So that's how that data size blew up from 2 million to 7 million, because it blew out all the products into new rows. That's a good question. It's kind of hidden, like the workings of this.
Reminds me of Python zip.
What's that?
Reminds me of Python zip.
Yeah, it is a good way of thinking about it. Like zipping lists together and zipping tuples together. So the next thing I wanted to show here is this is just a DuckDB specific thing. I'm not going to spend too much time on it, but you can treat this now as either you can now refer to these unpacked products data frame. You'll see this unpacked products and unpacked products is what this is. It's what we call this data frame, this arrow table. So PyArrow, which don't get into the specifics of that unless you want to go research that. But this PyArrow table or Pandas data frame, it's fine either way. You can refer to whatever you want. Unpacked products data frame, you can now refer to it in the from of your SQL statement. So you could actually now work with unpacked products data frame. You see here 2 pandas. So I now have pandas data frame, but I just called it from Python. I just used Python knowledge like Python to call that. And then here you see I'm calling it with SQL. And then I'm sending both of them to pandas data frames. That's what both of these are. And then I did the assertion. Oh, actually, I needed to, yeah, of course they're equal because they're both underscores. All right, so I needed to run this and this PDT assert frame equal. If it returns null, then they're equal. And if it returns something, it means they're not equal. So if not, which is why that not is there. So we're just seeing that both of these are the same thing. And you can refer to it now in either SQL or Python, however you want to refer to it moving forward. And all that's going on in this next step is we're just selecting the columns. So SQL does not have a drop statement, as you may know. You have to just select explicitly all your columns, which in a production system, you probably have a better way about doing that. That's just how I did it here. Selected all those columns. You'll see product ID, quantity, and price. I moved over kind of towards the beginning. They were just at the end. I moved them forward and got rid of the struct and list columns because we don't need them anymore because now we have all our product information. The next thing that I see, I'm kind of moving from left to right in this data frame now, is the timestamp. The timestamp is being read in as a string type because I'm seeing this T and all this stuff, and I know this is not how I want to work with a timestamp. So these are just, now it's like the next couple things are data cleaning. I don't want to go too deep into just the various data cleaning pieces of this. So we'll just turn this, but you might notice this from Python, the strp time. So this is a Python command that, not because it's available in Python, it's available in DuckDB, but DuckDB has made it available. And these are the kinds of tricks that are available in the data lake that are not available in tools like in RDBMS world and like Postgres. They have their own cool ways of dealing with dates and date times. But this like strip time reflecting what Python does. Now I can do it in DuckDB. I can do similar things in tools like Trino or Athena and like AWS. Like, there's really nice ways of working with date times. All I did here was tell it exactly how that column looks. I just gave it's kind of like regex, but for dates. I just gave it exactly how that data is structured, and it turns it right into the type of column that I need it to be. So you'll see now timestamp and timestamp 2. Timestamp, this is now a date column. So now I can do date operations with this. And in the data lake world, dates are a lot smaller than varchars. So if you can if you can move something from a varchar type or a string type to a date type, in the data lake world at least, they're taking up a lot less space and just what we're seeing so far. Varchars are going to take up a lot more space than these things will. There's been kind of like, I'm seeing like 30 to 40% reductions in storage sizes based on moving things from varchars to dates. And it gives you more complex like filtering operations, right? You can now like filter on this and partition. But a lot of times in the lake, we're going to partition our tables on a time variable like date, because that's how we're accessing them in systems downstream. Like I want to know sales over the last 12 months. So my table is then partitioned on month or week. I have a way to get to that level of information quickly. So you want a timestamp. You don't always want the time. Sometimes you might, but at least you want the day of when this event occurred. And if you remember earlier to how we introduced fact and dimension tables, again, this is a fact table. Like, this is all of our information. It's a fact table. This is the real world. This is what's going on. So now we have our timestamp. Next thing up is our product ID column. Yeah, how do I work with that, right? Like, why do I have product underscore before all of my number? Like, that's just redundant. I don't need that. Why is that there? Why do I have product in my product ID? That's what I'm saying. Like, the software engineers don't care. They're just gonna throw it at you and like figure it out, man. Like, and you're like, I don't need to work with that. You just like blew up my data size by 4 gigabytes. So how do I get rid of that product ID when I'm in my staging layer, right? I don't want to keep product. So I have a couple things that have to go on here. Luckily, I created this product ID, so I know there's no bad data. I know it's all like that. I know it's all product underscore and then a 1 or 2 digit number. So I know the pattern it follows, so I can extract that data. And again, this is really just to represent the power of data lake tools, because data lake tools, we now have a regex split to array. Like, that just feels like it was given from the heavens. Like a split to array, and I can tell you what I want to split the column on, and then it just sends it to an array. That's really cool. Okay, so I'm going to split product ID on the underscore. So now I just have product and a number. That's it. I just have a list with 2 entries in it now, and that's easy. Remember, we used our list extract, so we're gonna pull that again, and we're gonna tell it to pull that second thing. That second thing is always gonna be the number of the product, and we don't have to like define if it's a 1 or 2 digit number. We just know it's always a 1 or 2 digit. We just know it's a number. That's it. That's all we need to know. Yeah.
What would you do if you weren't sure about the structure of the product ID? Like, I mean, I'm just curious.
Yeah.
I wouldn't know what to do, so I'm asking.
So if you're saying like, because I know that product, it's always product, the word product, followed by an underscore, followed by a number. So what you're saying, what if like,
What if you suppose that 2 of them out of 20,000 are on a different pattern?
or what if there was an ampersand instead of an underscore? Or what if there was an exclamation point instead of an underscore? Like, what would I do? And that's why I call my data analyst and I say, I need you to figure out all the like wrong values that are in this column so I can deal with it. But no,
There's something that has to be done.
it has to be done. I'm sure we could look at it and we could find, like, depends on what variations there are. And we could probably look at it like, maybe this regex split to array, maybe I can't use it because maybe I can't always define that, like, it's an underscore. If I knew the whole universe of things, I could actually open this up, like brackets, and then I could say like it's either going to be an exclamation point or an ampersand or an underscore, and it could look for like any of those values that are inside of those brackets and like grab them, and it would still split them on those values. I guess another risk is like, what if there's an underscore before the word product, and then I grab the second thing, and all of a sudden the second thing is now the word product, and I'm trying to put that into my column, and you notice here I have a cast as int. Yeah, that's gonna fail. Like, that's not gonna work. But that's kind of why, that's also why I have the cast here, because the cast would catch that and it would try to convert the word product to an int, and it'd be like, nope, that we can't do that here. So that's part of why I have the cast on it, is to like, I know it worked if this runs correctly. And so the moment of truth, okay, great, it ran. And then you see over here, I have my product ID. That's a really good question, and it's just about like diving into your data a little bit deeper, and it's spending that like 30 minutes and trying to figure out like all the things that are up with it. And then maybe recommending a change at the source system. Like, if you have a good enough relationship with your software engineers, you'd be like, hey, could you not do that to me? Like, that'd be cool, thanks. Or just like working with your data analyst a little bit closer, working with your team to figure out like how we're going to deal with this. What are our edge cases? What's our data quality checks around this column, right? And like this thing. Does it say hand over here? Yeah.
Yeah, so why are we using SQL to perform these functions? Like, can we do like pandas operation in that?
Yeah, for sure. You could do it all in Python, for sure. I stick to SQL here because it's a more universal language, right? I don't want to force people to know pandas really well or like polars really well to be able to get enough from this exercise. And I was telling someone out in the hall, like, even I understand Python pretty well, I feel like, but even when I look at new Python code, it's harder for me to pick up than looking at new SQL code. Like, I can look at new SQL code and be like, oh yeah, cool, like select star, great. But like Python or like pandas would be like, they would like name the data frame, and then if you needed to do some like filtering, it would like open up the square brackets, and like once we start using brackets, like I could get confused. I was like, I don't want to show people that.
But like if you get used to like using pandas, I believe that it would be much simpler.
Yeah.
to do this.
Absolutely, yeah.
This is like
Yep, and so you would do this in like and again I'm talking about like Lake SQL type stuff. So there are tools out there like Trino and like Athena and AWS. Google has its own like Google BigQuery. These are like different tools where like you wouldn't use any of this Python. You would just use the SQL code to do this. But if you're working with a system that like has Python and your Python can hit your data directly, that's where we get into like issues of like how enterprise architecture is, and like if I'm using Python on my local machine, can I even establish a connection to my database? Like a lot of times my answer to that is no. Like I cannot hit my production database or even a development database. In my experience, all companies are different, but a lot of times you're not going to be able to go from like local machine to production data or development data or testing data. So you're going to be in an environment that your company kind of throws it on you, and they're like, hey, you got to use this to like hit the data. Like where I'm at right now with my client, the only way I can hit the data is by writing a Spark job and then writing a shell script to wrap that Spark job, and then I have to execute the shell script to run the Spark job, because there's a level of authentication I have to have as a user to be able to authenticate with the system, to then the system says, yeah, you're good, you can query the data. So I have to run a shell script to just run SQL code to hit my data right now. So like you never know what you're gonna like kind of get hit with. And I think having a base of SQL, like using a base of SQL in most instances, you're gonna be safe kind of whatever situation you end up in. Because not always you're gonna be able to use Python to hit these things.
okay.
That's just why I defaulted to SQL.
And yeah, I'm just following along with you, but my output is different than yours. So I guess that's
Really?
Yeah.
You might have, I mean, it's possible you generated different data, right? Like, or the data that got generated is different. If you did run that data generation step,
Yeah.
I wouldn't expect everything to be the same. Like, values are going to change and things, because
So
it's all
in the
random.
data generation step, we had to randomize something.
Yeah. Yeah, it's going to be super random, like whatever happens in there. Ideally, it's the same structure, right? Is it?
Yeah, it's the same structure.
Same structure.
but the user.
Good, that makes sense. Yep.
So more data issues, more job security, more people will be able to fix them. That is my first comment. Second comment is, other than VS Code, what else is installed there for user accounts?
Which part?
Other than VS Code, you have Python installed, and what else is installed in your machine to run this code?
I think that's
It
it.
should just be VS Code,
Yeah.
Python, and everything.
And the requirements
And the
file.
requirements,
Yeah.
which are all just libraries.
I can't step far away. I forgot. I gotta bring the mic with me if I want to like walk around like this. Yeah, should just be that. I don't even think you don't need Postgres or anything on your. You don't need a SQL instance on your computer to run this, and that's kind of why I formatted it like this to be able to use both.
Once I get the access to the GitHub, I can just download it.
Yeah, you should just be able to run it. Cool. Yeah, so we extracted that Python or that product. So now we have that product ID column. Fantastic. We can actually work with that. We'll throw away the product column the product ID column later, because now it's just taking up space in our database. And then we do that here. So the next thing I want to talk about, let me do a time check really quick. 7:47. Okay, I'm gonna try to fly. Like I said, I'm recording. The stuff is here. If you have questions afterwards that I didn't get to or about the code, like you're able to dive into the code on your own and like you have questions, ask me. And if I get like 3 of the same question, I'll record a video and then like send it out, because if like enough people have the same question, everyone else has it too. So I do want to make sure people are able to see this. All we're doing here is creating this dimension table. So you remember earlier we talked about dimension tables, we talked about products and other things. So here we're going to have staging.product type. And again, staging.product type. And we're going to look at what that table is now. So you'll see here, all this SQL code is doing is creating a scheme, like creating our staging schema. If it didn't exist, I knew it didn't exist, so I had to create it, and then create table if not exist, staging product type as. So a really great thing about Lake stuff is you don't have to like insert into and then execute many and do all those things. You just like tell it what table to look at. And I don't know about the RDBMS world, like what you would do in that situation, but you just tell it where to look, what data frame to look in. Here I'm pulling the distinct product IDs. And then adding just an example of comment about product. So now you see here I have this product table, and I'm able to give myself more context about what this product would be, like who's the manufacturer, what country of origin, like does the product come from, like things like that are now stored in this dimension table that are kept away from our fact data, so that way they don't take up room in our database. This function, don't spend too much time worrying about it. It's just doing the same thing. I just wrote a Python function to create dim tables for 2 other columns. So now we have 3 dimension tables. And I'll look at, so this is our event type dimension table. We didn't pay too much attention to it when we were looking at our fact data, but we had an event type column, which was just saying transaction complete. And this is definitely data that we want to know about, because maybe in here, you can have an event type, which is like failed transaction. And then you might want to know more details about that, like what failure code is associated with that failed transaction, and what then, who's like, maybe that's then connected to a product that then has like a supervisor. Like there's like context that we want to understand about transaction complete, transaction failed, transaction pending. Maybe if we're like an e-commerce platform and it stays pending for a long time, that would be really important to know for like a accounts receivable team, or maybe like an inventory team. Who knows who could use that data? Someone could use that data, and there's a level of context we want to get about that event type data. And then here we also have the payment type data frame. So if we drop down here, look at payment type. So again, we had Visa, Amex, PayPal, and MasterCard. And again, payment type info. Maybe we have a relationship with Visa and we have an account rep for our relationship with Visa. We would store maybe that level of information here. So that way we know who to go to when we have issues with processing Visa payments, right? Like event failed, like transaction failed, could then relate back to this level of data to know who to talk to, like when there's an issue. Just a wild example I just pulled out of my ass. And then connection, execute. So we're looking at all the tables that we have now. So we have our DuckDB database, schemas, landing, and we have staging, and we have those dimension tables that we created. Dim event type, dim payment type, and this should have been called dim product type. We always want to make sure we label like our dimension, our fact tables with dim and fact, so that way it's very clear like what that table is and what granularity we expect that table to be at. And this is just another way to do that, to look at the tables that we have. So the information schema.tables is a much more common way to query table information in tools like Snowflake and even in the RDBMS world. So again, we see DuckDB, landing, staging. We see base table. This would tell us if it's like a view or materialized view. We would have that level of information here in the information schema, and actually it might be like information table.views, for example. So that's what we know we have currently in our environment, but we broke away from our main table. So let's go back to our main table, right? The product, or the correct product ID, which is when we pulled out that product number. Now, this is something I'm glad I got to in the time that we have. What do we notice that's going on here? We notice that we have transaction ID, a user ID, session ID, and we have product ID. And remember, we talked about how the products like blew out when we created, like when we moved it from that struct type to the normal like primitive data type, and going from 2 million rows to now 6 million rows. Like it's a huge deal, because that's gonna like make our data take a lot longer to load, and processes are gonna take longer, our ETL jobs are gonna take longer, like everything's gonna take longer at this stage. So what, and then total amount, like I have price for a product, but then you see it's 3 times 24 does not equal 605. So that that means that this 605 is gonna show up on every row of that transaction. And again, it's gonna be redundant information. I only need to know one time in one place that the total amount was $605. But it's not a dimension table because it is still tied to the transaction, but it doesn't need to be tied to both the transaction and the transaction detail of the table that we're looking at. So we see a lot of things like that. We see discounts, we see shipping amount, we see shipping address, which a whole other problem in and of itself is dealing with addresses. Okay, so what do we do? You remember at the beginning, we had 5 tables that we created, and you see right here, we currently have 4. All right, we have 3 in the staging layer. We have 5 total in the staging layer. So this turns into 2 tables. We have 2 tables of information going on here. These are 2 granularities. Remember I talked about granularities too. Granularities are really important for fact tables. So the one fact table we have here is at a transaction ID granularity. The transaction ID, what's getting captured there? User ID, session ID, and then all the other columns. Total amount, tax amount, shipping amount. That's the transaction granularity. And then the transaction product granularity is the transaction ID with the product ID, quantity, and price. But it doesn't need any of the other information. We just need those 4 columns in our transaction detail table. And our transaction table just needs to maintain information about the transaction, but it's still a fact table because it's still a thing that happened. And then that's how these things start to get really hairy, is when you describe a fact table as description about a thing that happened, even though it is super important. So we're going to create our transaction filtered out detail here. And by the columns that we kept, we can tell that this is meant to be the table that only maintains a transaction ID granularity. So what we're going to do is we're going to dedupe the original table, partition by, and then we're going to do transaction ID. So if you're not familiar with also the window functioning in SQL, I highly recommend to look into it. I could have deduped this table because all I'm doing here is getting the unique transaction IDs. So I could have deduped this table by doing distinct transaction ID. What you don't, like, I guess what sometimes we don't think about is distinct is a terrible operation. Distinct is super slow because you have distributed computing power when you use something like a window function like we have here, but you don't when you run a distinct. Distinct has to pass everything through the same node and then collect essentially a set, because a set is like a non-repeatable list of items. And so it has to make sure it like passes everything through the same node, and it's checking to make sure that like, okay, we've never seen this before, and a window function does something similar, but in a distributed sense, because it's able to work over the partitions. It doesn't do that here because I don't have, the table's not partitioned, but when you're actually working with it in a lake, you want to work with it, you would want to do this on the partitioned column. So when you saved your parquet, you put it in a partition, whether it's a daily partition or a weekly partition, or even here, the transaction partition. And so now you're able to dedupe across, well, not the transaction partition, that'd be a terrible idea actually, but a date partition. And you can now dedupe within a day, but if you had 1,000 days you had to dedupe, and you have 1,000 nodes, each node can just take 1 day, and you're done. But in a distinct, it has to pass everything through the main node, and the main node is collecting. So if all your driver nodes can collect and then send it up to the main node, this is where we get really deep into Spark. But these things are a lot better to do in like a distributed sense, these window functions, as opposed to just a distinct. So when you're actually running on something that has that, you're able to make this work really well. Table name, sample fact transactions, it's because I deleted it, so it's not there anymore, so it doesn't need to drop. And we have our table. So we can look at the table, but I don't have too much time to do that. So we're just going to final staging transactions, create our final transactions table, and we're actually joining up the dimension tables to it. So you'll see here we have a from and the inner joins, and we're just going to fill in our aliases here for the tables. So we're just doing some inner joins. I will show you in a second what this allows us to walk away with. Reference table dim payment type, it's because I renamed it. And I shouldn't have renamed it. It's not dim payment type, it is payment type. Dim payment type again is somewhere else, right there. Dim payment, dim payment, dim event, dim event. Okay, I'm not gonna get too deep into that. There's something going on there. I renamed something and everything broke, so that you see that's the fragility of renaming things in your pipeline, because then everything will break. Somewhere I have something is called wrong, or I named something wrong, but what this table will get us is timestamp, transaction ID, user ID, session ID, and all of this information about our transaction table. And you notice we don't have any product information in here. And that's one thing we want to make sure we're very cognizant of, is not keeping that transaction detail. And so this is where we create that staging table. Again, the transaction detail, like I said, this is not as fast as I would want to move through it, but it is as fast as we need to move through it. We're going to do that same thing here, that row number, window function partition, to dedupe on transaction ID and product ID, which is now creating our transaction detail table. And you'll see here it only creates transaction ID, product ID, quantity, and unit price. That's the only thing. Oh, and that one did run. Okay, great. So we should see at least that table created here. Yep, we have that fact transaction detail in our staging layer, which is now the table we'll use when we want to move into a publishing zone. Cool. I moved really fast through that. I had to do a time check on myself. So it is 8 o'clock. If anyone needs to get up and leave in a hurry because they have a babysitter or something to do, Evan, then that's okay. But we're going to go through really quick, just wrap up. I'm glad I time checked myself a couple times there. We'll wrap up what did we build, because we didn't get to see one of these tables. It is there in the code. So we built that fact transactions table, which has those 3 tables attached to it, right? Those 3 dimension tables attached to it, the payment type, the event type, and there was another one, the product type. Now the dimension tables that describe our fact table give us more insight into that fact table. You'll notice over there we have that fact transaction detail. And so you'll notice also the connectors. We have one to many, and the dim to the fact is a one dim to many facts. And then the fact transactions is a one to many to the transaction details. It is important to know how your tables connect when you start doing joins, because you could start exploding things without meaning to. When you start doing things like cross joins, you're going to explode, or even outer joins, things are going to start getting really big and really hairy. So you need to also know how those tables connect, at what granularity they connect, all those other things. So there's some more information about it there. What did we build? What can the business do? So I just want to run through that really quick. Like which states bought the most of a product, discounts by product line, buying frequency, market basket analysis for our data scientist, recommendation engine, loyalty bands based on how much they spend. There's a lot of information we could do with this. Also knowing that like someone always uses a Visa, and then we see that like they use the MasterCard. I don't know, like random things like that. We may want to know these things about our customer base, that they're changing or making decisions, and these pieces of information. So we have a lot of analytics use cases. What differentiates a model, like a data model, versus not having a data model in the use case, and why it's important is, again, what I talked about earlier, the flexibility of being able to move things in and out of visualizations, reports, machine learning models even, and like allowing things to kind of move and flow. And now we have a vocabulary that we can use to talk about our data. We have an optimized structure. Things make sense. We have order to the chaos that we started with, which was just a bunch of transactions and a list and a struct type and product IDs that had the word product in them, and things that we just don't need in our data that really blow up the size of our data sets too, and things that make it really hard. So that is a lot of things. Continued learning. Data Warehouse Toolkit by Ralph Kimball, the definitive guide. It is the place to go if you want to learn more about this stuff. Like, get that book, read it cover to cover, and you'll have to give this talk next time because you're going to know it a lot better than I do. And then Khan Data Solutions. He's really great at explaining this stuff, and I actually reference back to some of his stuff. I'm not like asking for money, but I don't know, whatever. I have my stuff up here. If you want to donate to this event specifically, that would be great. If not, also fine. I didn't ask for any money because I just wanted to make sure we could get this event like working, and the complexity. There were a lot of complexities putting this together, so I did not want to add in another layer, which is charging people money to come to this. Next time we will have a monetary element to that, again, just to pay for the pizzas. So I have my Venmo and my PayPal up here. If you just want to send a couple bucks, totally fine. Again, it's just to pay for that stuff out there. And I think that is, February meeting plan. Docker and Docker Compose. So data engineering is data focused, but we also touch the infra world sometimes. So today you notice we had to create a virtual environment, install DuckDB. That was really annoying. No one liked to do that. So with Docker and Docker Compose, we reduce the amount of issues we might run into. Some of you might have run into issues. Some of you might have Python 3.5 and like DB is not it, like they're not compatible with Python 3.5 or like 2.7. I don't know, like maybe you had some old Python version. There's a lot of problems you can have when you're trying to pass code to other people, and then even with virtual environments, like you run into problems. So Docker and containers are a way for us to avoid those problems. Usually you'll wrap an application up into a container, then you start getting into things like Kubernetes and tools that I don't really understand super well, but I do know Docker Compose pretty well. So we're going to talk about those next time. We're going to talk about the benefits of building a container, and like we did today, we're actually going to build a Docker container. We're going to have at least a Postgres instance in it, if not something else. I'd like to build kind of a mini application inside that Docker container. So ChatGPT, here I come, and we'll talk about that more next time. But if you have any questions, definitely come up, talk to me, like let me know what you thought of this, and I think that's it. That is all I have